Today's lecture is direct memory access. In this method, the transfer of data into or out of the memory unit through memory bus, transfer of data between a fast storage device such as magnetic disk and memory is often limited by the speed of the CPU. Removing the CPU from the path and letting the peripherals device manage the memory bus directly would improve the speed of transfer. This transfer technique is called direct memory access. During the DMA transfer, the CPU is idle and has no control of the memory bus, and DMA control take over the bus to manage the transfer directly between the input, output and memory. The CPU may be placed in idle state in variety of ways. One common method extensively used in microprocessor is to disable the buses through special control signal such as bus request and bus ground. These two signals in the CPU that facilitates the DMA transfer. Bus request input is used by DMA controller to request the CPU. When this input is active, the CPU terminates the execution of the current instructions and place the address bus, the data bus, and read-write line into high independent states. High independent states means the output of is disconnected. This is diagram of DMA transfer signal, CPU signal. There are two signals, bus request and bus granted. In left hand side, address bus, data bus, read and write operations. First of all, we have to obtain the bus request for transferring the data. After accepting this DMA controller, data are transferred, data bus, and then bus is granted to permission to send any information through data bus. The CPU activate the bus grant output to information the external DMA that the bus request can now take control of the buses to conduct memory transfer without process. Where DMA terminates the transfer, it disables the bus request line. They disable the bus granted, take the control of the bus and return to normal operations. The transfer can be made in several ways that are DMA burst and cycle steering. And DMA burst transfer, the block sequence consisting of number of memory words is transferred in continuous burst while the DMA controller is master of the memory bus. Cycle steering allows the DMA controller to transfer one data word at a time, after which it must return control of the bus to the CPU. DMA controller needs the usual circuit of interference to communicate with CPU and input-output device. The DMA controller has three registers: address register, word count register, and control register. Address register is contain the address to specify the desired location in the memory. Word count registers, which is write control holds the number of words to be transferred. The register is increased or decreased by 1 after each word transfer and internally tested for 0. Control register. Control register specifies the mode of transfer. The unit communication with the CPU via the data bus and control bus. The register in the DMA are selected by the CPU through the address bus by enabling the DMA select and RS register select input. Read and write input are bidirectional. When BG is bus guaranteed input is 0, the CPU can communicate with DMA register through the data bus to read from or write to the DMA register. When BG equals to 1, the DMA can be communicate directly with the memory by specify an address in the address bus and activate the read or write control. This is diagram for block diagram of the DMA control. Data buffers are used for buffering of the data. In the data will be selected and register select, read, write, bus request, bus guaranteed and interrupted. DMA are send the request in unidirectional to send. DMA send the request to sending the data. After acknowledgement, we have to obtain the input-output device from the request to DMA controller, and after getting the acknowledgement input-output, all data are transferred internally bus, which is controlled by address registers, word count register and control registers. DMA transfer. The CPU communication with the DMA through the address and data buses as with any interface unit. DMA has its own address which activates the DS and RS line. The CPU initializes the DMA through data bus. Once the DMA receives the start control command, it can transfer between the peripherals and memory. When BG equals to 0, the RDN write input lines allowing the CPU to communicate with the internal DMA registers. When BG equals to 1, the read and write are output line from DMA controller to random access memory to specify the read or write operations of data. In this method, interference is point where the connection is made between the two different parts of system. The stop control method of asynchronous data transfer employs a single control line to time each transfer. The handshaking method solves the problem of stop and method by introducing a second control signals that provide a reply to connections that initiate the transfer. The program input output mode of data transfer. The operations are the rest in input output instructions, which is a part of computer program. In the interrupt initiate input output method is an interrupt facilities. An interrupts command is used to inform the device out about the start and end of transfer. In direct memory access, the interference transfer of the data into and out of the memory unit through the memory bus.